Hello and welcome to e-sipnayan. For today's video, we are going to discuss how to solve rational equations. The learning objectives are the following. First, distinguish irrational equations, then solve rational equations. We begin by defining what rational equation is. Rational equation is an equation that contains one or more rational expressions. Recall that a rational expression is simply a ratio of two polynomials. Some examples of rational equations are given here below the slide. First, we have 1 over x equals 1 over 5 minus x. Another example would be x plus 4 over x equals negative 5. And last example, we have x squared over x plus 1 equal to 1 over x plus 1. So notice that in all of the examples given here, there is a presence of rational expressions. And that is how we define rational equations and some examples. Moving on, let's discuss how to solve rational equations. Before we proceed to actual examples, let me share to you the 3 steps that we will be following in solving rational equations. First, we will be solving for the value of x. Then, check if the solution is a true solution to the equation. Lastly, decide which solutions are considered. Now, for step 1, we will be utilizing our knowledge and skills in solving algebraic expressions to be able to solve the value of x given the rational equation. For number 2, this is the checking part. We will see if the value of x that we were able to obtain from step 1 is a true solution to the equation. Why do we need to do this? What is true solution? Does that mean there is a false solution? The answer is the presence of the term extraneous solution. So, extraneous solution is actually a false solution to the rational equation. When does a solution becomes false? It happens when the solved value of x does not satisfy the equation. Later on, given the examples, we will be explaining when the solution is true or false. Then lastly, we will be deciding which solutions are considered, and we will only be considering true solutions. True solutions, on the other hand, are the values of x that when checked satisfies the given equation. Let's now have the first example. We have x over 5 plus 1 over 4 equals x over 2. The first step in solving rational equations is to solve for the value of x. We will be using our algebraic computational skills to be able to isolate x and therefore solve for its value. Notice that on the left-hand side of the equation, we have here 2 fractions that we need to combine first before we can solve for the value of x. Now, to be able to combine x over 5 plus 1 over 4, we need to write them as one fraction by getting their LCD. The LCD of 5 and 4 is equal to 20. Now, we rewrite the left-hand side of the equation in such a way that the LCD becomes 20, or both denominators rather becomes 20. So, we have now 20 divided by 5, that is 4, times x, so we are going to have here 4x. Added to 20 divided by 4 is 5, times 1, we get 5. So basically, we can combine them as one fraction by writing it as 4x plus 5. We simply combine the numerator, then we copy the denominator as 1. So the left-hand side of the equation can also be written as 4x plus 5 over 20. Now, let us rewrite the equation this way. The left-hand side becomes now 4x plus 5 over 20, whereas the right-hand side stays as is. We will simply copy x over 2. And this is now the new equation we will work with. Moving on, we'll now solve for the value of x. So what we can do here is to cross multiply. So we will multiply 4x plus 5 by 2. So that becomes 2 times 4x plus 5. And it will be equated to the product of 20 times x. So that is 20x. We need to further simplify so that we can isolate x. So what are we going to do next? We just need to distribute multiplying 2 to the binomial inside the parentheses. So that becomes 2 times 4x, we have 8x, plus 2 times 5 is 10, equated to the value of 20x. Now, since our plan is to isolate x, we need to combine all x's onto one side of the equation. That leaves us 10 only on the left-hand side of the equation, equated to 20x. From positive 8x, it becomes negative 8x. And so, simplifying further, we get 10 equals 12x. And to finally isolate x, we divide both sides by 12. So, this will be cancelled, and therefore, the value of x will now become 10 over 12, or that is equal to 5 over 6. And this is now the value of x, and we are done with step 1. Now that we already have solved for the value of x, which is 5 over 6, we shall now proceed to step 2, which is the checking part. We will simply check if the solved solution of x is indeed a true solution to the equation. So how do we do that? We will simply substitute the value of x to any of this form of the equations, and then we will see if the equation will be satisfied. So basically, we will simply let x be equal to 5 over 6 given this option or this one. So the original form is x over 5 plus 1 over 4 equals x over 2, and the rewritten form, combining the fractions on the left hand side, we have 4x plus 5 over 20 equals x over 2. So you can choose any of the following when substituting. Now for this case, I'll be using form number 2. So I'll let x be equal to 5 over 6 given 4x plus 5 over 20 equals x over 2, and see if the equation will be satisfied. Now for the checking part, it's quite simple since we are just simply going to substitute the value. So that becomes 4 multiplied to the value of x, which is 5 over 6, added to 5 all over 20 equals, on the right hand side of the equation, we will still be substituting the value of x. So after this, we are now going to simplify. Now we have 4 times 5, that gives us 20, added to 5, divided by 20. Then on the right hand side of the equation, we are dealing with a complex fraction. So that becomes 5 over 6 multiplied to 1 over 2. So simplifying this part, we have 20 over 6 plus 5 over 1. We can get the LCD. The LCD is 6. 6 divided by 6 is 1 multiplied to 20. That's 20. Added to 6 divided by 1 is 6 multiplied to 5. That gives us 30. And this will still be all over 20, which is the denominator on the left-hand side of the equation. Meanwhile, on the right-hand side, we will simplify these factors. We have 5 over 12. Moving on, we can further simplify the numerator on the left-hand side of the equation by having 50 over 6, but it will still be divided to 20, and that is equal to 5 over 12. Now, we are checking if the left-hand side is equal to the right-hand side of the equation. The left-hand side can also be rewritten as 50 over 6 multiplied to 1 over 20. And we are checking if it is equal to 5 over 12. So we can further simplify the left-hand side by making this 5 and 2. And so that will give us a product of 5 over 12, which is basically equal to the right-hand side of the equation, which is also 5 over 12. And so that will lead us to the last step, which is to decide if the solution can be considered as a true solution. When do we consider a solution as a true solution? It happens if when you are done checking, the equation will be satisfied. And in this case, since the left-hand side and the right-hand side equation are the same, then we can say that x equals 5 over 6 is indeed a true solution to the equation. And we're done with example number 1. Let's now have the second example. Y plus 3 all over y minus 1 equals 4 over y minus 1. So at this point, we are going to proceed immediately with the step 1, which is to solve for the value of x. Now, unlike on the previous example, the left-hand side and the right-hand side of the equation only contains one fraction, so this is already good to go. To simplify this easily, what we can do is to multiply both sides of the equation to y minus 1. Notice that the denominators for both sides of the equations are the same. And so what we can do is to multiply y minus 1 to both sides so that they can easily be cancelled. So that will give us y minus 1 multiplied to y plus 3 over y minus 1 equal to 4 over y minus 1 multiplied to y minus 1. After this, the denominators will now be cancelled. Then, this is an easy part already. What's left are the following. We have y plus 3 on the left-hand side of the equation, and that is equated to 4. To isolate y, this becomes 4. 3 is being transferred to the right-hand side, so that becomes negative 3. And so the value of y is equal to 1. Notice that the variable used here is not anymore x but y, but it can be any variable in general. So this is now the value of y. Step 2, simply check if the solution is a true solution to the equation. How do we do that? Again, we just need to do the checking. So let's check if indeed y is a true solution by substituting it to the original equation. So we will let all y's be equal to 1 given the equation. So that becomes 1 plus 3 all over 1 minus 1. We are checking if it will be equal to 4 over 1 minus 1. So the left-hand side can be simplified as 4 over 0, while the right-hand side becomes 4 over 0. Notice that the left-hand side and the right-hand side are equal, but there is a problem here. Any number that is having a denominator of 0 will give us an undefined value. So if the value is undefined, definitely we cannot get any value in reality. So although the left-hand side and the right-hand side are equal, if it becomes undefined, then this is already a false solution. Therefore, y equals 1 is a false solution, or what we call the extraneous solution. So, basically, since this is an extraneous solution, we do not have actually a solution for the rational equation.